So welcome to our pre-calculus video on partial fraction decomposition. So what we're trying to do is we're trying to decompose a rational function into the sum or difference of two or more rational functions. So you know, or we know, that you can take the two rational expressions, 2 over x plus 3 minus 5 over x plus 2, and you can combine those to get this, negative 3x minus 12 over x squared plus 5x plus 6. What we're going to learn how to do is to do the opposite. That is, start with this and decompose it into that. So starting with this, ending up with that. And the reason we want to do that is because this expression is going to be easier to work with than this in calculus. So what we're doing is we're starting with a rational function, and a rational function, recall, is the quotient of two polynomials. We're calling it rational function r. So it's the quotient of polynomials p and q. And q, our polynomial with real coefficients, can be written as a product of linear factors and or irreducible quadratics. So linear factors are factors that have x just raised, the largest degree is x raised to the first power. And then irreducible quadratics are quadratics that can't be factored further without complex numbers. So like x squared plus 4 is an irreducible quadratic factor. So we can take q and break it down into linear and irreducible quadratics. Now our strategy for partial fraction decomposition is going to be based upon the denominator q right here. So this q, we're going to factor it into linear and irreducible quadratics. And then for linear factors, we're going to write expressions that have a constant numerator, as we're going to see. And for quadratic factors, we're going to create expressions with linear numerators, that is, with numerators that have a degree x to the first power. And then the third rule we want to keep in mind is that if factors are repeated in q, we're going to have separate numerators for each progressive power, as I'm going to illustrate. So let's see how this technique is going to go. So let's find the partial fraction decomposition of x plus 10 over x squared minus 4x minus 12. So the first order of business is factoring that denominator, the q. So this is going to become x plus 10 divided by x minus 6 times x plus 2. And what I can see is that those factors in q are linear, right? X to the first power. And my rule says when you have linear factors, and they're not repeated, but when I have linear factors, I get a factor, I get an expression with a constant in the numerator. Let me go back up here. So whenever I have linear factors, I get a constant in the numerator. So here's what you do. You first say, okay, I get a constant, so a is some constant, divided by the first factor, x minus 6, and then x plus 2 is a linear factor as well, and so I get some other constant, call it b, divided by x plus 2. And the idea now is that these two expressions have to be equal to each other. So what I'm going to do, let me erase this, it's easier to work with. What I'm going to do is I'm going to multiply both sides of this equation by x minus 6 times x plus 2. I'm going to clear denominators. So x minus 6 times x plus 2. And then same thing on the other side. Just into a bracket. And so what happens is these cancel, of course, and the left-hand side is x plus 10. And the right-hand side is going to be a times x plus 2 plus b times x minus 6. And so remember, what I'm trying to do in this is I'm trying to find the constants a and b. Because if I find the constants, then I will have taken this and decomposed it into the sum of these two expressions. So in that quest, x plus 10 is equal to, and what we're going to do on the right-hand side is we're going to distribute the a and the b, and then we're going to group combine like terms. So this becomes ax plus 2a. Remember, 2a is just a constant, plus bx minus 6b. And so the like terms would be the ones with x. So it's going to be x plus 10 equals a plus b. I'm going to factor out the constant x, not the constant, but the common x that they have, and then plus 2a minus 6b. So now I look at the left-hand side and the right-hand side, and these are equal to each other. So whatever has x on the left has to be equal to the expression with x on the right. And so the coefficient here is a 1 on the x right there. And so that 1 must be equal to the coefficient here, because these are the only two terms with x. So I have 1 is equal to a plus b. That's my first equation. And my second equation is the constant here, 10, is equal to the constant over there. So it's 2a minus 6b is equal to 10. And then I have a system of equations that I have to solve for a and b. So I'm going to multiply the top equation by negative 2. Then I'm going to add those together. And I'm going to get, let's see, well, let me write them out first. Negative 2a minus 2b equals negative 2. 2a minus 6b equals 10. So I'm looking at negative 8b is equal to 8. So b must be equal to negative 1. And then from here, right, that a plus b is equal to 1, right, that condition is true. And if b is equal to negative 1, then a has got to be 2. So I found my a and my b. And so that means that I take the values I found, the a and the b, and I plug them back in here. So my partial fraction decomposition is this. It's going to be a, which is 2 over x minus 6, and then plus b, so plus negative 1, or you could just write minus right there, over x plus 2. That's the partial fraction decomposition of x plus 10 over x squared minus 4x minus 12. So my answer is this. So you can check it, right? If you add these together, you should see that you get that. And so all we've done is taken this and we've decomposed it into two rational expressions that are going to be easier to work with in calculus. All right, let's try one that's a little more complicated. So let's find the partial fraction decomposition of 2x minus 8 over x to the 4th plus 4x squared. So the first order of business is factoring that denominator. So 2x minus 8 over x squared times x squared plus 4. And this is an irreducible quadratic because it's quadratic and I can't reduce it any further. Now this is x times x. So this is quadratic, but it's actually a product of two linear factors. So I have the linear factor x and it's repeated, right? I see it 2 times. So this is not an irreducible quadratic, but that is. And when you have repeated factors, you get a term for each progressive power of that. So this is going to break down into, I first get a over x, and you can think of that as that was for the first power of this. And then, of course, it's x and then x squared. So I get another one, b over x squared. And if this was like x to the 5th, I get b over x squared, c over x cubed, d over x to the 4th, e over x to the 5th. So for each progressive power of a factor, you get another term. Okay, and in this case, because they were linear factors, I'm getting constants. And then finally, this is an irreducible quadratic, and for irreducible quadratics, we get linear factors in the numerator. So it's going to be cx plus d because that's the most general linear factor. It's got x raised to the 1st power, and c and d are constants. So that over the irreducible quadratic x squared plus 4. And now what I want to do is I want to multiply both sides by the LCD. So it's going to be x squared times x squared plus 4. Okay, and so we're going to get 2x minus 8 is equal to ax times x squared plus 4 upon distribution plus b times x squared plus 4 plus it's going to be cx plus d times x squared. And then I want to distribute, so I've got 2x minus 8 is equal to ax cubed plus 4ax plus bx squared plus 4b plus cx cubed plus dx squared, combined like terms. 2x minus 8 is a plus c cubed, x cubed, plus it's going to be b plus d, because those are the terms that have x squared. And then x, it's going to be 4ax, and then the only constant is the 4b. And then I remember that the left-hand side polynomial is equal to the right-hand side. Now the left-hand side doesn't have any cubed or squared terms in it. So the coefficients of those would be 0, right? Like 0x cubed and 0x squared is one way of seeing it. So the a plus c must be equal to the 0. That's my first equation. And then likewise, my b plus d must be 0 because there's no x squared term on the left. So b plus d is equal to 0. And then my linear term 4ax is equal to 2x. So the 4a must be equal to 2. And then the constant 4b must be equal to negative 8. So right away I can see that a has got to be 1/2. B is equal to negative 2. And I can use those values to find my a and my c, because I see that c is negative of a. So c must be negative 1/2. And then d is negative of b. So d is equal to positive 2. So these are my constants. And I'm going to take those and I'm going to plug them in here to get into this, because that is my decomposition. So my answer is a, so it's 1/2, 1 over x. I plugged a in right there. And then b, so it's going to be minus 2 over x squared. And then plus cx plus d. So plus negative 1/2 x, and then plus d plus 2 over x squared plus 4. So that is the decomposition. That's my answer. That's the decomposition of this 2x minus 8 over x squared times x squared plus 4. All right, that's it.